Good morning, dear students. Here I am explaining the construction of Turing machine for this language, and most of the students have asked this problem to explain, but it is not possible to come to the classes right now, right? So that's why I am doing this video for you guys, and especially for the students who were absent in the last 10 days of working days. So even that students also they didn't attend the classes. So for them I am doing this video. And one more thing, so whatever we have explained in the classroom, so that is we have gone with the concept, so it looks a little bit tough. So that's why briefly here I want to explain how you need to remember this problem. Okay, so let's start our problem. So Turing machine, so for this language, a power n, b power n, c power n, where n greater than or equals to 1. In the sense, here we are having three symbols a, b, c, and the powers of the symbols are same. If you are taking 1 in the sense 1a, 1b, 1c. If you are taking 2 in the sense 2a, 2b, 2c. So that's why first of all we need to write the language, and we will see the overall structure of this solution. First we will write the language. Later we will consider one input tape. So from this input tape we will consider any one of the string as the example. So we will read each symbol by symbol. While we are reading the symbol itself, we will have one transition diagram, and transition functions we will represent in the form of a table. So this is the transition function table. Okay. So it's your wish, guys. You can write the table first, later diagram. Otherwise, you can draw the diagram first, later table. That's your wish. Okay. So here I will explain brief concept of it. Then it's your wish, whatever you want to choose first. Okay, so first of all I am starting with the language. If you have taken n is equals to 1 means 1a, 1b, 1c. If you have taken n is equals to 2 means 2 a's, 2 b's, 2 c's. If you have taken n is equals to 3 means 3 a's, 3 b's, 3 c's, and so on. This is a infinite language. From these strings we can consider any one of the string to read. So in the input tape here I am considering the string AA, BB, CC, and here we will have some blank symbols. Here capital B in the sense blank symbols. So right side it is infinite, and left side also we will have some blank symbols, and this is also left side it is infinite. All the cells will be filled with the blank symbols. You already know that. So now here we will read symbol by symbol, and while we are reading the symbol, in the parallelly we will draw the diagram and as well as the transition functions. Okay, so first of all we will leave the blank symbols at the left side. We will start with the original symbol of the string, that is nothing but the first symbol A. So initially any transition diagram it will start with the initial state, so that is nothing but the Q0. Okay, so from Q0 state here we are reading the first A, and remember guys, here our target is to prove the number of A's and the number of B's and the number of C's are equal. So that's why we will check like this. For 1A, first A, first B, first C matching. Okay, so whenever we found the one pair matching, and again we will search for the second A, second B, second C matching. So like that we will check. Okay, so and finally we will read blank symbols before going to the final state. And one more thing, here if you see the transition function table, here we are having states in the first column. Next the variables, the symbols A, B, C, and these symbols will be changed to the external symbols X, Y, Z, and later finally we have the blank symbol. Okay, so now we will see, while we are reading the first A it will change to X, and next A's will be neglected, and while we are reading the first B it will be changed to Y, and next B's are neglected. While we are reading the first C it will be changed to Z. Okay, so whenever we have found first A, first B, first C matching, and immediately we will come back, means left side. Okay, so this is a Q0, this is the scenario we need to follow. So from Q0 we are reading the A. Okay, so this first A will be changed to X. So that's why since the symbol is changing, state also will change. Here we are having A, so that is changing to X, and we need to move right side. This is the transition function. So this one we can represent like A slash x and right side right arrow mark. We can represent in that way also, no problem. Okay. And next one is, we will move to the state Q1. From Q1 we will read the second A. While we are reading the second A, it will remains the same only, means a self loop. A remains A only, we need to move right side again. So this one is over. Okay. So next we are reading the first B. From Q1 state, while we are reading the first B, that B will be changed to Y. Since the symbol is changing, state also will change. B is changing to Y and we need to move right side and we will move to the Q3 state. Again from here we will read the second B. While we are reading the second B, the symbol won't change. So that's why self loop. B remains B only, we need to move right side. Next we will read the first C symbol. While you are reading the first C, it will be changed to Z. So since, this is a Q2 state, it will change to Z. Since the symbol is changing, state also will change. From Q2 to Q3 state we will move. Here we will write C is changing to Z. Here we won't move right side because 1A, 1B, 1C already matching found. So that's why we need second A, second B, second C. We will have second A, second B, second C again from right side onwards, from back onwards. So that's why whenever we found the first C matching, immediately we will come back and we will read the second A, second B, second C symbol. So that's why we will move left side here. Okay. So after that, while we are coming back in the way to the back side, so we will read all the symbols whatever encountering in the path. So that's why from Q3 state we will read first, we will touch with Z. So that's why Z remains Z only, we need to move left. After Z we will touch B. B remains B only, we need to move left. After that we are touching Y. So here this is not the first B now. So this is already changed to Y while we are going this side. So that's why now we will read the Y symbol newly. So that's why Y remains Y only, we need to move left. So after that we are reading the A symbol. A remains A only, we need to move left. We will follow this until we have reached the X. But whenever we are reading the first X, in the sense one iteration is over, means one looping is over. Okay, so that's why from Q3 state, while we are reading the X symbol, one iteration is over, we will come back to Q0. X remains X only, while we are reading the X, then the remaining symbols are right side. So that's why we need to move right side, not the left. Okay, so we need to move right side. Again from here, we will read again the second A. So this second A again it will change to X. So that is what we have already written here. So this is enough. It is enough for this one. Okay. And right now we are in Q1 state. So you just don't confuse while we are going back for the second time. You just remember A, B already there. So on Q1 loop here extra we will get Y. Y remains Y only, we need to move right side. And on Q2 self loop here we will get one more new function, Z remains Z only, we need to move right side. These are the extra things we need to write. So for that again while you are checking on the input tape and everything, so you may get confused. So that's why you just remember like this. A is changing to X, B is changing to Y, C is changing to Z. Okay, and in the meanwhile A self loop, B self loop. Here we will have all the symbols Z, B, Y, A, all these symbols. Whenever we are reading the X, we will come back again. And from here again for the second time here we will have some new symbols. That's why Y, Z, right again once again. Okay, so after completing all the symbols, okay, while we are coming back, we will read again X, Y, Z as the external symbols without any ABCs now. So that's why while we are adding the X remains X only, we need to move right side. Here we will change the state Q4. Okay, this is only the situation where the symbol won't change but the state will change. Okay, Again, after that, here we have y symbol and z symbol. So that's why take a self loop here. Y remains y only, move right. Z remains z only, move right. And finally, after completing all the symbols, finally we will read the blank symbol from this Q4 state. Whenever we are reading the blank symbol, we will move to the final state, that is nothing but Q5 state. Here blank symbol remains blank symbol only, we need to move left side or right side, you can write. Okay, so this is overall the transition diagram for the Turing machine. If they have given for 0 1 2, then instead of ABC you will take 0 1 2. If they have given 1 2 3, instead of ABC you will take 1 2 3. So nothing will change, same concept, same transitions, same states. Okay, so here from this transition diagram we need to write the states, we need to write the transition function table. Okay, so here you need to remember, if they have given 3 variables, any combination, okay, so we will have these many states. Okay, Q0, Q1, Q2, Q3, Q4 and Q5 are the states. If they have given only two symbols, means a power and b power n, then the states will be less for this problem. Only Q4, up to Q4 states we will have. Okay, one state less. Okay, now if you have seen here, from Q0 state, A is changing to X. This is the symbol we need to consider. A is changing to X, Q0 state. Here we need to write not this one as it is here. Okay, so state is changing, A is already here, right? So that's why here we will write the state from Q0. While we are reading the first A, we will move to Q1 state, and A is changing to X, and we need to move right side. That is the difference here. Okay, so right now we are in Q1 state. From Q1 we will read the second B and everything. So this one I will tell later. First of all, see, Q0 state, A reading, we are reading A, so it will change to X. From Q1 state, again we will read B, so it will change to Y. So that's why state also changing. Q2, B is changing to Y, we need to move right side. Again from Q2 state, we are reading the first C, that is nothing but C will change to Z, so that's why Q3, C will change to Z, and we need to move left side. So these are the transition functions. And here we need to write some more thing also. Here, after we have reached to Q1 state, here we are having self loops. A remains A only. Q1 state, A. Self loop, A remains A only, means state also not changing, self loop. So that's why Q1 only, A remains A only, we need to move right side. For the self loop, we are writing this transition function. In the same way, for Q2 state, here we are having B, means Q2 state, B means self loop. Q2, B remains B only, we need to move right side. Even on the self loop, here we are having something, right? We will write that one also. What? On Q1 state, we are having Y self loop also. Q1, we are having Y self loop. We are on the same state, self loop covered. Q1, Y remains Y only, we need to move right side. On Q2 self loop, here we are having Z. Q2, we are reading Z. Self loop Q2, Z remains Z only, we need to move right side. Next, C is changing to ZL. So that one we have written here already. Here instead of the symbol state we will write, that's it, that's the difference. Okay, ఇక్కడ C రాసాం కదా, సో ఇన్స్టెడ్ ఆఫ్ దిస్ C, టు విచ్ స్టేట్ ఇట్ ఈస్ మూవింగ్, C ఆల్రెడీ ఇక్కడ ఉంది కాబట్టి వీ విల్ రైట్ టు విచ్ స్టేట్ ఇట్ విల్ మూవ్. ఓకే, if it is goes to Q3 means we will write Q3. If it is on the self loop means we will write the same state name, that's it. So on Q3, here we are having 4 self loops. These 4 functions we need to write now. Q3 state, first one Z, Q3 Z means self loop. Since it is a self loop, Q3 Z remains Z, move left. So next one is B, Q3 state B here. Self loop kabatti Q3 remains Q3 only, B remains B, we need to move left. And again here we are having Y self loop. From Q3, Y self loop. Q3 remains Q3 only, Y remains Y only, we need to move left. And here we are having A self loop. Q3 state A self loop. Q3 remains Q3 only, A remains A only, we need to move left. Okay, again from Q3 here we have one more transition also to Q0 state. So that is X. Q3 X. So it will move to Q0 state. X remains X only, we need to move right side. Okay, so again from Q0, here again we have some new transition, right? From Q0, while we are reading the X symbol, what we will write here? We will move to Q4 state and X remains X only, we need to move right side. Okay, so that's why again Q4 state. On Q4 state we will have the self loops. Q4 state, here Y self loop, while we are reading Y. Q4 Y. Self loop kabatti Q4 only, Y remains Y only, we need to move right. And here we have Z also function. So that's why Q4 only, Z only, and we need to move right side. And finally from Q4 we are reading the blank symbol. Q4 we are reading the blank symbol. So we will move to Q5 state and B remains B only, we need to move left side or right side. Okay, so right now we are in Q5 state. For the final state there are no transitions, and here whatever the leftover functions are undefined transition functions, these are. So you just keep the hyphens in the place of them. Okay, so this is the overall design or construction of the Turing machine for this language. So instead of this language, if they have given 0, 1, 2 or 1, 2, 3, whatever the combination they have given, okay, you no need to tense about it. Okay, so you just follow the same scenario, you can able to solve any type of problem in these constructions. And along with it, if they have given for the 15 marks problem, please don't write only this one, you need to extend the solution. Means you need to explain something else regarding this. While we are reading the first A, what is going to be happen? While we are reading the first B, what is going to be happen? So that thing you need to write in some paragraphs or in theory. Okay, so then only you will get the full out of full marks. Okay, so this is the solution for this problem. I hope you can understand. Thank you.